Welcome to Lab Rats. Come with me and let's take a deep look into what allows us to see this incredibly beautiful world that's all around us. Light. What is your favorite color? Mine is green. I absolutely love that dark forest green color. All the colors that you've ever seen, those are all because of light. But that's not so surprising, because at night when you go home, if you turn off your lights, you really can't see anything. It is black. So where does this light come from? Today, there's lots of sources of light, but throughout history, humans needed the sun. It wasn't until humans, using science, developed these light bulbs and other light sources. So let's focus on the sun. The sun gives us white light. It's white because it's so hot. It is 10,000 degrees Fahrenheit. Whoa! And white light is all the colors put together. What do I mean by all the colors? I mean the colors of the rainbow. Red, orange, yellow, green, blue, indigo, and violet. The rainbow. So, what makes these colors different? Light is a wave. And just like ocean waves, they can come in different sizes. We call them wavelengths. Our eyes and brain perceive these different lengths of light as different colors. Red light has the longest wavelength, about 750 nanometers. Violet light is the shortest, about 400 nanometers. Let's take a ride on a beam of light and see from the light's point of view. The white light, which contains all the colors, starts at the sun. And then it travels 100 million miles all the way to Earth. And maybe these waves hit a leaf of a tree. Some of that light stops there. The plant absorbs it to make its food, but it doesn't absorb all the light. What's left bounces right off that leaf and then reaches your eyeball. Your eye sees those wavelengths of light and your brain processes it as the color green. Light waves will interact with stuff that's all around us. Sometimes it gets absorbed, other times it gets reflected. But light waves still interact. Who's seen a rainbow? Rainbows are formed when the light interacts with the water in our atmosphere. Sometimes as clouds, other times as the raindrops. Those raindrops are prisms, and they can separate the light. But how? While the speed of light is incredibly fast, the different wavelengths of light will interact with the matter differently. Sort of gets in its way and it has to move. So when light hits the raindrop, they move differently, and that allows the light to separate into all the different colors and make a beautiful rainbow. The white light is all the colors of the rainbow smushed together. We can actually recreate this phenomena with a simple glass prism. If you pay attention, you might find that there's a lot of prisms all around us. You can see little rainbows form on bubbles, oil slicks, or even CDs. And the sun isn't the only light source. We also have a lot of different types of light bulbs. Are all light sources the exact same? Well, no. You might see some lights that look very yellow, or others that look a little bit more blue. Some look just pure white. I want to show you a simple build that you can do so you can see all those differences of light. You can actually split light into individual wavelengths and see what wavelengths exist from each light source. Let's do the experiment. For this experiment, all you're going to need is a disposable plastic cup, some duct tape, scissors, a CD, and thick paper like cardstock, maybe an old flyer, some business cards, whatever you have around. First thing you're going to do is grab that red Solo cup. Now we're going to be cutting a hole out of the bottom of this cup. Cutting a hole out of this thick plastic can be dangerous, so ask a parent or guardian or sibling to help you. There are multiple ways to cut it. You can use scissors, a small drill, a sharp knife. There's a lot of ways to cut it. Once you finish cutting your hole, it's going to look like this. It doesn't have to be a perfect circle. You just need a hole in the bottom. To make the spectroscope work well, you want to allow only a little bit of light to actually come through. I'm going to use 2 business cards. You want them 1 to 2 millimeters apart, and you can actually use a third business card to sort of separate about that distance apart. Once you have them the right space, you can add 2 small strips of tape to keep them in place. Make sure that once you've added the tape, there's still a hole in between. Allow the light to come through. Next, flip over your cup. You want to place this over the top of your cup. The light will be coming through the crack in the middle, and to keep it in place, you can just fold each 4-corner down. Once they fold down, it'll sort of place itself, grab onto the ridge of the cup, and won't move anymore. Once you've done that, now you can start covering it up with some duct tape. You want to leave about 1 inch of crack open for light to come through. The rest of it you want to completely seal with duct tape. You don't want to allow any excess or extra light coming through other than that little crack in the middle. Once you're done, it'll look like this. Now we're going to be using our CD. You want to cut a small segment off the CD. It'll look like this. You can roughly cut 4 to 6 segments from a CD. Once again, cutting anything thick like plastic can end up being sharp, and it can always be dangerous, so be very safe while doing this. We want to remove the surface of this CD. Now this little shiny surface, it's easy to remove with a little bit of duct tape. Place it on a strip of duct tape, and when you slowly peel it away, you'll realize that this shiny surface comes right off. The plastic is what you want. This acts like a prism. It's actually called a diffraction gradient. This will separate the light like a prism and allow us to see the rainbow that makes up the light that we see. You're going to place it right over the small hole that you cut earlier from the bottom, and the hard part is where to place it. You need to make sure that it's actually aligned properly with the light source, the slit of light coming in from the top. So look through the eyeglass and rotate it slightly until you see the big rainbow bar. Once you see the rectangular square, you're good, and you can tape it down in that position. You're going to add a lot more tape to this now. You want to leave about a 1-inch square or smaller, just big enough for your eye to look through. That'll be your eye hole. So add a bunch of tape to make sure that no excess light comes through. You want to look through the side of the CD, and you want to point the slit towards any light source. Now, if you don't like the look of duct tape like this, you can design it in any way you'd like. Maybe paint it or color it and design it in any way you want. Once you've fully sealed it from light coming in, now you've made your own spectroscope. Congratulations, you've built your very own spectroscope, a device that allows you to break up light into its component colors, so you can really see what colors are making up the light that you're seeing. Go outside and look at the sunlight. Be careful here. Do not stare directly at the sun. Don't point this directly at the sun. If you look at the sun, you can damage your eyes. To look at sunlight, stare off at a cloud, or maybe on a bright surface on the ground. But don't stop there. Check it out and check out a lot of different light sources, like different light bulbs in your house, screens in your house. All those sources might be very different or very similar to each other. Go check it out. Here's a color changing LED. The bar on the right that you see is actually the hole. That is the slit that the light is coming in from. The band on the left is the colors that you will see that make up the light coming in. And as the colors change, you will see the bands appear and disappear depending on what color is coming through. I got one final question for you. If your eyes see these different wavelengths and your brain processes them as color, do we all see the exact same colors? Think about it and drop your answer on any of our social media accounts @BrainstemTV. Happy sciencing!